Welcome back, viewers. Today I want us to look at scale drawing, and in this particular question I want us to apply the surveying technique. It is an area that may be tested this year, and to help us understand this better, we're going to look at the question that is given. In question 1, you are told that measurements of a wheat field using a baseline XY were recorded as shown below. The measurements are given in meters. Now the baseline from X to Y, we have 20 to 240 meters. And then we have the right and the left offsets from H to P. Now in question 1, using a scale of 1 centimeter to represent 20 meters, draw the accurate map of the wheat field, 5 marks. And then in Roman 2, find the area of the field in hectares. So to help us do this, we are going to get a sheet of paper, and on the space that will be provided to you by the examiner, you will use that space to make an accurate scale drawing of this field. So you get your ruler, pair of compass, and a set square. So we start by drawing a straight line. I'm going to draw my field start with the baseline like that, and I'll pick a point at the bottom. This point I'll call it X. This point here I'll call it X, and at X I'm going to draw a horizontal line. Of course that line should be perpendicular to the vertical line. It starts up a bit. Like that. And then, because you're told to use a scale of 1 centimeter to represent 20 meters, 1 centimeter to represent 20 meters, from X, which is 20, I'm going to draw 1 centimeter. 1 centimeter. So I'll take my ruler and pair of compass, measure 1 centimeter. And put a mark. From here, put a mark. 1 centimeter. Put a mark like that. And then the other part, we have the right offset, 20 meters. Again, 1 centimeter to the right, to H. Now here I want you to be very keen. We want to use the slide rule to draw that horizontal line for the right offset. So place your ruler and set square like that, and where you marked 1 centimeter, slide your set square up to that area and draw a horizontal line like that. And because this is 1 centimeter, pick that measurement, 1 centimeter, step here, mark that point, call this point H, so this is 1 and this is also 1. From that point, the next distance on the baseline will be given by 50 minus 20. 50 minus 20, that gives you 30. 30 divided by 20 gives you 1.5. So get 1.5 centimeters from your ruler. 1.5. Step here, mark off 1.5. And at that point, the offset now is to the left. Again, 30 meters. Take 30 divided by 20, mark off 1.5 to the left. So take your set square again and ruler using the slide rule. Draw a parallel line to H from the offset and to your left, draw the line. And mark off 1.5. Mark off 1.5 like this. 1.5, 1.5. 1.5. Call that point P. And then from 50 on the baseline we go to 100. So 100 minus 50, that gives you 50. 50 divided by 20 gives you 2.5. So go to your ruler, mark off 2.5 centimeters. Like that. And step on the baseline, strike an arc at 2.5. So at 2.5, the other offset is to the right, to J, 100. So 100 divided by 20 gives you 5. So draw a parallel line to P using the slide rule method. Draw a parallel line. And the offset is to the right, like that. And measure off 100 divided by 25 centimeters. Measure 5 centimeters on your ruler. and strike an arc. You can extend this line like that, and then call this point J. From 100, the next point is 120 minus 100, which is 20. 20 divided by 20, 1 centimeter. Mark off the baseline, 1 centimeter, strike an arc, and then the other offset is to the left. Draw a parallel line to J, like that, and measure 1 centimeter. You strike an arc. So from J, the offset is to N, 100. The offset is to N here, not 20 but 100. 100 divided by 20, that will give you 5. So we can extend this line. Measure off 5 centimeters. Strike an arc there, call that point N. The next point on the baseline is 150, given by 150 minus 120, which is 30 meters away. So 30 divided by 20 gives you 1.5. So measure 1.5 on your ruler. Measure 1.5 on your ruler, and then come and make a mark here, 1.5. So the next offset is to the right and is at 50 to K. So 50, we draw a parallel line to N. We draw a parallel line to N. Like that. And measure off 2.5 centimeters. And call this point K. Of course, you can label the measurements as you continue. So here we had 1, 1. This is 1.5. at the bottom we have 1.5, and then 1.5 followed by 2.5. This is 1.5. This is 5 followed by 1 followed by 5 followed by 1.5, then to K we have 2.5. It's going to help us when calculating the area. So we can continue from K to L on the baseline. We are now here from K to L. On the baseline, it will be given by 180 minus 150, which is 30. 30 divided by 20 gives you 1.5. So you measure 1.5. Strike an arc here, 1.5. And then draw a horizontal line now to K. Like that. And the offset is to the right to L and is given by 80 here. So 80 divided by 20 gives you 4. So measure off 4 centimeters from your ruler. And you mark off from the baseline. Mark that point, call it L. L. Here write 4 and here write 1.5, like that. The other distance on the baseline is given by 190 minus 180, which is 10. 190 minus 180, which gives you 10. So 10 divided by 20, 10 divided by 20 gives you 0.5. So on your ruler, measure 0.5 centimeters. And you make a point here, like that, and draw a horizontal line to L. And the offset is to the left, like that. So here write 0.5. and to the point M, it is given by 60 meters. So 60 divided by 20 gives you 3. So mark off 3 centimeters. And on this line here, strike an arc. Right here 3. And this point is M. And then to the point Y now, we have 240 minus 190, which gives you 50. 50 divided by 20 gives you 2.5. So mark off 2.5. And you strike an arc here and mark this point Y, and write here 2.5. Now what we need to do is to join these points now from X through N. Start at X to H, H to J, J to K, K to L, L to Y, that, Y to M, M to N, N to P, and P to X. Now that is the map that is required of the wheat field. So you can see it is made up of different regions. We have got triangles and trapezius making that particular region. So what we need to do, we need to find now the area. We have to calculate the area of the region in hectares. Now we can divide this into regions. We can call this A, can call this B, can call this C, can call this D, call this E, can call this F, call this G, this H, and this region can call it I. Now you can go ahead and calculate the area. We start with the area of region A. Area of region A Area of region A. Region A is given by a triangle of base 1 centimeter by height 1 centimeter. So the area is given by a half times 1 times 1, which is the same as 0.5. The area of B is given by, B is a trapezium. The parallel sides are 5 and 1, and the common height is given by 2.5 plus 1.54. So area will be given by half times the height, which is 4, times the sum of the parallel sides, which is 6. So half times 4 times 6, which gives you 12. The area of region C is given by, C is also a trapezium. The common height will be given by 2.5, and the sum of the parallel sides will be given by 7.5. So a half times 2.5 times 7.5. So using your calculator, confirm that. Using your calculator, is equals to 9.375. 9.375, like that. And then the area of region D is also a trapezium. The common height is 1.5. The sum of the parallel sides will be given by 6.5. So a half times 1.5 times 6.5. Work out that using your calculator. I'm going to get a value of 4.875. Area of region E. E is given by a triangle. E is a triangle. The base is 4 and the height is 3. So a half times 3 times 4. This gives you 6.0. Area of region F. F is a triangle. The base is 3 and the height is 2.5. So this is given by half times 3 times 2.5. That gives you can confirm using a calculator, 3.75. And then we have the area of region G. G is a trapezium, parallel sides 3 and 5. The common height is given by 1.5 plus 1.5 plus 0.5, 3.5. 3.5. So a half times 8 times 3.5. Half times 8 times 3.5. Confirm that using your calculator. That gives you 14.0. The other area is H, region H. H is a trapezium. The common height 3.5 and the parallel sides, the sum of the parallel sides 6.5. So area of region H is given by a half times 6.5 times 3.5. $11.375. The other area is I, the area of region I. I is a triangle, the base 1.5 and the height 2.5. So a half times 1.5 times 2.5. This gives you, working out with your calculator, confirm that. $1.875. So we can now get the total. Having exhausted all the regions, we can get the total in centimeters squared because we are dealing with centimeters. So you can add all that 0.5 plus 12 plus 9.375 plus 4.875 plus 6.0 plus 3.75 plus 14 plus 11.375 plus 1.875. That gives you 63.75 centimeters squared. Have it here, 63.75 centimeters squared. But we are told to give our answer in hectares. Going back to our scale, 1 centimeter represented 20 meters. Therefore, 1 centimeter squared would represent 400 meters squared. 400 meters squared. So what about 63.75? What about 63.75 centimeters squared? So we are going to take 63.75 multiplied by 400. 63.75 multiplied by 400, that gives you 25 25,500 meters squared. This gives you 25,500 meters squared. And we know that 1 hectare is equivalent to 10,000 meters squared. So how many hectares would be equivalent to 25,500 meters squared? So you divide this by 10,000. So we're going to get 25,500 divided by 10,000. 5,500 divided by 10,000, that gives you 2.55 hectares. So it will be equivalent to 2.55 hectares. So that is how you ought to have worked out that particular question, or that is how you ought to work out a similar question in case it is brought to you in the examination. Thank you for watching. Kindly like, subscribe, and share.